In 10.1d, we're going to construct and interpret confidence interval to compare two proportions. So very similar to a single proportion, we can find what's called the two-sample z-interval for the difference between two proportions. That is the method name that you can list as you do your state plan, do, and conclude. For the confidence interval, it's just like it was for a single proportion, but we're going to find the difference. So remember, this is the mean right here. So if it's for the difference, we will subtract the two p hat values. We're going to do plus or minus our critical value using a z-score. And then remember, this is the standard deviation. So the standard deviation is increased variability. So to combine the two, you add them, variances, and then take the square root. So this is considered to be the standard error, or you may hear it referred to as the estimated standard error. And this information will be found on the AP formula sheet. Let's walk through one complete example using state plan, do, and conclude. Presidential approval here. Many news organizations conduct polls asking adults in the U.S. if they approve the job of the president is doing. How did President Obama's approval rating change from August of 2009 to September of 2010? According to CNN, a poll of 1,024 randomly selected people were asked in 2010, and 50% approved. Then the CNN poll in 2009, they asked 1,010 people. At that time, 53 had approved. Use these results to construct a 90% confidence interval for the change in Obama's approval rating among all U.S. Adults. So we're going to decide, do we want to find the difference of 2009 minus 10 or 2010 minus 2009? As long as you're consistent, it doesn't matter. I think it makes more sense, though, to say that we want to actually estimate the proportion of 2010 minus the proportion of 2009 so we can see if it went up or down. We are going to do a 90% confidence interval, and let's define that P sub 2010 is the true proportion of all adults who approved President Obama's job performance in September of 10, and P of 2009 is the same approval but for August of 2009. Now, the plan portion for this, let's just state the test, that we are going to perform a two-sample z-interval for P of 2010 minus P of 2009. This is actually all you have to state. Again, all you want to choose, is it one or two sample, is it Z or T, and are we doing an interval or a test? Now, let's confirm the conditions. Remember, random independence and normalcy still holds. So for random, the data came from separate random samples, so we were good. For normalcy, we do need to show that for both the first set of data and the second, that they're both at least greater than or equal to 10. Here we have the calculation, final answers for both of those components, so it meets that it's approximately normal. For the independence, the samples were taken independently, and there are more than, again, 10 times our sample size for each. We can assume more than 10,240 U.S. adults in 2010 and more than 10,100 back in 2009. Therefore, we've met the independence condition. Now to construct the test, if I want to show the written format, I could. This is actually what it would look like. Remember, it's going to be p hat 10 minus p hat 9 plus, let's talk about the critical value. Recall, we want to be 90% confident. So on the critical value for 90% confidence, that's the area under the curve. However, we know that means there's 10 more percent in the two tails, so this is actually 0.05 in that tail. So in terms of our Z statistic or our critical value, we want to find from here all the way down. So we have to do an inverse norm at 95%, 0, and 1. So inverse norm at 95% with a mean of 0 and standard deviation of 1 gives us a critical value of 1.645. Now if we simplify this confidence interval, what we're going to see is we get the final confidence interval of a negative 0.066 up to a positive 0.006. Now personally, I am going to go to the calculator on this one instead, so let me show you the calculator keystrokes that you would follow. All we're going to do is hit the stat button one more time here and go to stat tests. Now this time we are looking for a true proportion Z interval, which is letter B. So just scroll through it and look for it. We know it's two proportions, we know it's a Z, and we know it's the interval for the test, and just look until you find it. When you click on that, you're going to be asked for the outcomes of success over the sample size for each of the two samples. Type that in accordingly. This must be as integers. Never on an interval or a test do you put the proportion here. You just put the counts for x and n. And we want a 90% confidence interval. So I'm going to calculate that, and lo and behold, here's what we get for our interval, which is the same as if we calculated it by hand. Now, I do recommend that you jot down this key information and just put that on your page. Because we probably already have it there, but it's always good to kind of have it backed up. So we have the p-hat1 and the p-hat2 along with their corresponding sample sizes. Now, based on that, let's make a conclusion for our confidence interval. What we're going to say for that is we are 90% confident that the interval from negative 0.066 to positive 0.006 captures the true change in the proportion of U.S. adults who approve of President Obama's job performance from August 2009 to September of 2010. If we wanted to try to make a conclusion from that, one thing you could say that it is plausible that his job performance has fallen by up to 6.6 percentage points, which is our low end here, or increased up to 0.6 percentage points. So then more formally, based on your interval, is there convincing evidence that Barack Obama's job approval rating changed from August 2009 to 2010? Well, let's write down what the interval was again. This was the specific interval. Now, the question is there convincing evidence that there has been change? So think about what no change means. No change means the difference would be 0. Does this interval include the difference of 0? Absolutely it does. So it means it's a possibility it could fall in this interval. Therefore, we would have to say, since 0 is included in the interval, it is plausible that there has been no change in President Obama's approval rating. Thus, we do not have a convincing evidence that his approval rating has actually changed, because our actual confidence interval does include what we think the true difference may have possibly been. Now, I am going to caution you one more time. We've talked about this AP mistake that happens. If you use the calculator for the two proportions of the interval, which again I recommend that you do, but if you type something in incorrectly, it means you're going to get the wrong answer. If you do that, you will receive no credit for the do step. So they do recommend to show the formula with numbers, then use the calculator. If they don't agree, then it could be scored. Now, what I recommend doing is first just use the calculator on your calculations and then move on and finish the exam. If you're done and you have time, I would then go back and double check these calculations with actually doing the formula. Odds are you've typed it in properly, but what if you didn't? You don't want to drop from a 4 to a 3 automatically just because of a typo in your calculator.